Okay, so we are going to start discussing, we're going to kind of go off the path of the topics that we've been discussing the past couple weeks and go back and touch over domain and range of a graph. Okay, so we're going to talk about the coordinate plane a little bit and identifying parts of a coordinate plane to make sure you understand this before we start graphing quadratics. Okay, so the first page is all notes about coordinate planes. So what is the definition of a coordinate plane? Anytime that you hear coordinate plane, you should automatically picture this picture in your head. Okay, you should automatically picture this. This is what a coordinate plane is. So the formal definition of a coordinate plane is a plane divided into four regions, and those four regions are also known as quadrants, used for graphing data. Okay, typically in class you'll be writing this, but I'm writing it for you and you're just paying attention and going along with it. I will screenshot this and post it in notes as well. So parts of the plane, you have the origin. The origin is right here in the center. This point in which the X and Y axis intersect right in the middle is the origin. Then you have the quadrants. The quadrants are quadrant 1, top right quadrant, quadrant 2, top left quadrant, quadrant 3, bottom left quadrant, and quadrant 4, bottom right quadrant. It's a little odd how they number these, but those are the four quadrants, 1, 2, 3, 4. They start in the top right and they go counterclockwise. The x-axis is this axis, the horizontal line. And the y-axis is the vertical line, the vertical axis. So those are the parts of the coordinate plane. Hopefully you know all those. Hopefully the only information that you may have forgotten was the labeling of the quadrants and which quadrant was what. Okay, an ordered pair. If I wanted to identify and label a point on a coordinate grid, I would use an ordered pair. So an ordered pair is a point written as x comma y located on a graph. Hopefully you all know that. And if I wanted to name points on a graph, I'm given a graph and I've got point A, B, C, D, E, F. If I wanted to name the points using ordered pairs and identify the quadrant, point A is here. How would I write that point as an ordered pair? You'll be surprised how many people still do not know this. I'm going to start at the origin and I'm going to go left or right first because my first number in my ordered pair, my x values, I need to move along the x-axis first. So from the origin, I'm going to go left 3. If I go left 3 spaces from the origin, that's negative 3. That is at the point where x is negative 3. And then I need to go up along the y values, 1, 2, 3, 4. I need to go up to where y is positive 4. So that point is written as negative 3, positive 4, and it falls in the second quadrant. Point B, from the origin, I'm going to go along the x-axis first to positive 2. So my x value is 2. My y value is down 1, 2, 3. Down 3 is negative 3. And that is in quadrant 4. Point C, right here, this is the most common mistake made. I'm neither going to move left or right along the x-axis. I'm going to remain where x is 0. So x is 0. And I'm going to move up where y is 2. So if you do not move along the x-axis left or right, then your x is 0. Part D, or point D, I'm going to move to the x positive 3, where x is positive 3 and y is positive 1. And that is in the first quadrant. I skipped the quadrant for point C for a reason. I'm going to go back and touch that in a minute. Point E is right here. From the origin, I'm going to go left 2. So I'm going to go left 2 to negative 2. And I'm going to go down 3 to negative 3. And that's in the third quadrant. And the last point, F. Now this one's a little bit different than C. For C, I didn't move left or right, so I remained where x is 0 and y is 2. For point F, I'm going to move along the x-axis, 1, 2, 3, 4, 5 times, so x is 5. But I'm not going to move up or down for y. I'm going to remain where y is 0. So your y is 0 in this case. Now these 2 points, point C and point F, neither one of those lie on the in any quadrant. They lie on the axis. So right here for point C, you would say it falls on the y-axis. And then point F, it falls on the x-axis. So your points will either fall in a quadrant or on an axis. Okay, the last 2 definitions that I'm going to remind you, you've actually already seen these. All graphs that you've seen all year long have been either discrete or continuous. I'm going to touch over continuous first. Continuous, if you just in general think of the definition of continuous, what does it mean when something is continuous? It continues forever and ever, and it never stops. It never breaks. It never has gaps. Okay, so a continuous graph is a graph of connected lines or curves. It continues. So if I have a coordinate grid, that's as straight as I can draw using this pad. Sorry, guys. If I have a coordinate grid, my continuous graph may look something like this. I can trace the entire line without picking up my pencil. But a discrete graph, if you want to make a conjecture about a discrete graph, if a continuous graph is a graph of connected lines or curves, what do you think a discrete graph is? Well, a discrete graph would be a graph of distinct points. With breaks or gaps. Okay, it's a graph of distinct points with breaks or gaps. I'm going to draw 2 different graphs here. So, of course, we have our graph of just points that aren't connected. Okay. A discrete graph could also look like this, where you have lines where the lines are not connected. So you may have a segment of a line here, and it stops, and it picks up here where y is a different value, and it continues and stops. And then it may pick up way down here and continues. Okay, so there's gaps. I cannot trace from the left side to the right side without picking up my pencil. So that's also a discrete graph. Okay, so now we're going to move on. Let's see, rotate clockwise. To relations. And we've already talked about everything in this page here. We've already talked about everything on this page here. We're just going to touch over it again. If you look at the PDF, this last row doesn't have values, so we're just going to scratch through it, not even worry about it. We're just going to look at the top 2 rows. Okay, relations. What is the definition of a relation? You've already been given the definition of a relation in your book at the beginning of the year, but a relation is just simply a set of ordered pairs. A set of ordered pairs. And a set of ordered pairs is a relation until it's determined to be a function. And a set of ordered pairs is only a function if x values do not repeat. Okay? So the set of all x values is called the domain. It's called the domain. The set of all y values is called the range. And the little hint that I gave you all at the beginning of the year, what comes first in the alphabet? X or Y? X does. What comes first in the alphabet? D or R? D does. So X and D, X and domain go together, and Y and R, Y and range go together. Okay, that's a quick, easy thing to remember. My X and D comes first in the alphabet before Y and R. Okay, that's just a little silly Miss DeWitt trick. All right, so ordered pairs. For your domain, when you have a set of ordered pairs and you want to identify and determine what is the domain of those ordered pairs, the domain are my x values. The range is my y values. So I'm looking at only the x values for your domain. -3, -2, 1, 3, -3. Okay. However, we do not repeat the same value twice, okay, when writing our domain. So we know that this is not a function because -3 repeats. So if I want to write my domain as a set value, I'm going to write them in order from least to greatest without repeating any x values. So my greatest or my least number is -3, -2, 1, and 3. Now I'm going to change my code to blue. My y values are 1, 0, 2, -4, +5. So if I want to write that set of values, I would write -4, 0, 1, 2, and 5. And if I wanted to put those ordered pairs in a table, my x values are the first number that shows up in the ordered pair. My y value is the second number. So -3, 1 would be -3, 1. -2, 0. +1, +2. +3, -4. -3, +5. So that's how you transfer your order pairs to a table. And then mapping, you've seen mapping before. We have X, we have Y, we have domain and range. Okay. So my domain X values, my range Y values go on the right. I'm going to use, because I've already written my set notation here in numerical order, I'm going to use my set notation to fill in my map. And then to represent my ordered pairs here, I'm going to use arrows. I'm going to draw an arrow from -3 to +1 to represent -3, 1. From -2 to 0 to represent -2, 0. From +1 to +2 to represent 1, 2. From 3 to -4 to represent 3, -4. And from -3 to 5 to represent -3, 5. And you can also say that this is not a function because right here I have 2 arrows. Whoops, I meant to change that to blue. I have 2 arrows that are pointing from the same x value, which tells me that that x value, that -3 value, repeats. So this is not a function. And I could have said that right here because -3 and -3 repeats. Okay, and then to put those points on our graph, I would go -3, +1, left 3, up 1 from the origin. -2, 0. -2, 0 is to the left 2. Stay on where y is 0. 1, 2 is right 1, up 2. 3, negative 4 is right 3, down 4. And negative 3, 5. 1, 2, 3, 1, 2, 3, 4, 5. Your graph should look like that. Okay. I'm going to leave this one blank for you to do on your own if you would like. So this is a self-study. Okay, self-study for you to do on your own. All right, let me switch this one to counterclockwise. All right, so now we're going to start talking about the domain and range on an actual graph. On a graph, what does the domain and range look like on graphs? Okay, I'm going to try to zoom in and make this as big as possible. Okay, so for our domain values, we know that domain are the what values? The x values, which fall on the x-axis. And we're going to scan our pencil from blank to blank. My x-axis was my horizontal axis, so we're going to scan from left to right for our domain, for our x values. And for the range is my y values along the y-axis. And we're going to scan our pencil from top to bottom. Top to bottom or up to down, however you state that. Same thing, top, bottom, up, down. Okay, so here's some examples. Number 1, we have a graph here. If I wanted to scan this graph to list my domain of this graph, I'm only looking at my x values for the domain. I'm only looking at x values. What x values does this line graph cover? Well, it covers all x values for infinite and forever and beyond to the left. And then it covers all of these x values along here and all these x values along here. And then it still continues forever and for beyond to infinity to the right. So if you take a piece of paper and you cover up your graph going all the way to the left, you'll see that the arrow continues to go off your paper to the left. And if you need to cover up your paper to the right, you'll see that if I go to the right, my arrow continues to go forever and beyond to the right. Because it continues forever to the left and right, your domain is all real numbers. All real numbers. Now your range for this one is a little bit different. Because if I scan my graph from up down, from top to bottom, I know that my graph is going to cover all my y values all along this all along the y values for all points from this point and above, because it continues to go up and it continues to go up in both directions. So if I got a piece of paper and I wanted to trace and cover up this graph for all the values going up, you would never get to a point. But if I got a piece of paper and covered up this graph going to the bottom, usually I use this example in class and you can visually see the piece of paper covering the graph. My piece of paper would get to this point and you would not see the graph any longer. So this point is where y is 2. Negative 2. So to write this range value, where does this graph touch my y values? This graph touches all values of y such that y is greater than or equal to negative 2. Ooh, that kind of messed up a little bit. Greater than or equal to negative 2. Because where y is negative 2 right here, it touches all points that are greater than y along this graph. Okay, for number 2, I have a circle that is inside the graph and it doesn't continue on in any direction, which means my domain and range both are going to have boundaries, okay? So my domain, my x values, where does this graph stop going to the left? Where does it stop going on the x-axis? Right here. My graph does not extend beyond this point where x is negative 3. And then to the right, it doesn't extend beyond this point where x is positive 3. So my graph only lies between the values of negative 3 and 3. So you always put your smaller number to the left, negative 3, your larger number to the right, positive 3. What variable represents domain? X variable. And then you put a less than equal sign in between the two. Always put less than equal sign in between your smaller number, larger number, with the variable of the domain, x, in the middle. Okay, so this reads x is greater than or equal to negative 3, which is true, greater than or equal to negative 3. However, x is less than or equal to positive 3. It's less than or equal to positive 3. So x only falls in between those two values. Now for your y values, for your range, my circle does not extend beyond this point at positive 3, and it does not extend beyond this point of negative 3. So I'm going to put my smaller number on the left, my larger number on the right, my variable that represents range, less than equal. Okay, so for number 3 and number 4. Number 3, if I'm looking at left to right, it covers all my values to the left and then it extends. Covers all my values to the right and then it extends. So from the left to the right, it covers all my x values forever and beyond, so it's all real numbers. And then if I'm looking at my range from top to bottom, it covers all my values of y going up to the top, and then this line is going to continue going up. This line is going to continue going down to cover all my y values going down. So my range is also all real numbers. And if you got a piece of paper and covered it up, going up and down, left and right, you'll see that you will never be able to line that graph paper up to an ending point of this line in either direction, up, down, left, or right. Number 4 is a little bit different. Going to the left, my line is going to continue going forever to the left to cover all these values of x to the left and the right. So my domain is going to be all real numbers. It continues on for the left and it continues on for the right. Okay, but my range, I can say that my range values stop right here. I have a distinct line where I can say my graph does not extend beyond this point where y is positive 4. But going down, it continues forever and beyond going down. So this means that all my y values are all values of y such that y is less than or equal to 4 because it's going down. It's covering all my y values less than 4 from that point. Okay, number 5. Number 5, I have a graph that is entirely on the grid, which means that I'm going to have endpoints for my domain and range in all directions. Okay, so for my domain, to the left, it does not extend beyond this point where x is negative 1. For the right, it does not extend beyond this point where x is positive 5. So x lies between negative 1, positive 5, less than equal sign. For top to bottom, y does not extend beyond this point where y is positive 3. And it does not extend beyond this point where y is negative 3. Therefore, y lies between negative 3 and positive 3, and fill in my less than equal sign. I'm speeding up a little bit because hopefully by now you got it. Looking to the left of this graph and looking to the right of this graph, where does this graph stop going left? Well, it continues going left and it continues going right. Looking at it going up and down, it continues going up and it continues going down. So the domain and range for both of this is all real numbers. All real numbers. I cannot draw a distinct line saying that this line stops here going up or here going down or here going left or here going right. Okay, because that arrow says that it's going to continue. Okay, a few more. I'm going to do 7, 8, 9, 10, and then the last 2 pages on this PDF document are for you guys to do. For number 7, going left and right, I cannot draw a line going left because this arrow says it's going to continue. I cannot draw a line going right because that arrow says it continues, so it's all real numbers. I cannot draw a vertical line left or right saying that the line stops here. But if I look up and down, my line stops here and my line stops here, where y is positive 2 and negative 3. So my line lies between negative 3 and positive 2. Okay, so for number 8, for my domain, my y values, or my x values, my x values do not extend beyond the left part of x is negative 1. But I cannot draw a vertical line to say it stops to the right because my arrows say that it continues going forever and beyond to the right. So this means that all my x values have to be greater than or equal to negative 1. Going up and down, I can't draw a line going up because this says that this line continues going up forever and beyond. And this says it continues going forever and beyond down. So my range is all real numbers. All right, number 9 and number 10 is a little bit different. They're a little bit more difficult. If you can't tell, this line is right here. It's a straight vertical line. And then this line is right here. It's a straight linear horizontal line. Okay, so where does this line stop going to the left? Well, it doesn't point to the left. Where does it stop going to the right? Well, it doesn't point to the right. So let's skip that for a second. Neither goes left or right. But I can easily say that it goes up forever and beyond, and it goes down forever and beyond, so my range is all real numbers. But what's my domain if the line neither goes left or right? Well, the key here, the domain and the range simply state where do my values touch the x values, where do my values touch the y values. So where on this graph, where does this line touch? Where x is what? What x values does this line touch? That line touches all x values where x is positive 2. So x equals 2. What that means is all x values of that line is 2. So if I wanted to, let me change to purple. This point here, well, that's not a good color to use. Let's use lime green. This point here is 2, 3. X is 2, y is 3. This point here is 2, negative 1. 2, negative 1. This point here is 2, negative 1, 2, 3, 4. Negative 4. Okay, this point here is 2, positive 1. So as you can see, all your x values for all those points are just x equals 2. Over here on number 10, I have left and right as being forever and beyond to the left and forever and beyond to the right. So my domain here is all real numbers because it covers all numbers to the left and all numbers to the right. However, my range going up and down, it neither goes up or down. It covers all values along where y is negative 4. Y is negative 4. So it's all values where y equals negative 4. If I want to put a point here, it would be at negative 4. Let's see, negative 4, negative 2. If I wanted to put a point here, it's negative 4, positive 3. Put a point here, it's negative 4, 0. and forever and beyond. So all your, oops, hold on. Y'all let me make a mistake. I wrote all those backwards. I was so stuck on my X values over there. I just wrote all those order pairs backwards without even realizing it. Let's start over. This would be -2, -4. This point would be 0, -4. And this point would be +3, -4. Okay, so all your y values are -4. All your y values are -4. Okay, so if you see a vertical line, your domain is just where that x equals where that vertical line is. Your range for a horizontal line is where y equals wherever that line falls on the y value. Okay, so what your assignment is, you are going to complete, and this is just a combined review of what we just did all together. Okay, you've got your domain and range from an order pair set, your table, your map, your graph, and then you've got graphs where you identify the domain and range of all of them. Okay, so you're going to do these 2 pages. It's not very many problems, and you're going to submit it to me in a PDF doc. You're going to save the PDF doc, annotate on the PDF, and then submit it back to me. I'm going to open up in your classroom. I'll show you. In the classwork, in third hour, I just realized that this is at the top of the page. I need to move that to the bottom where we actually are. In domain and range, you'll see the domain and range worksheets in your classroom. Okay, I'm going to post another assignment underneath here that will say domain and range homework submission, and you're going to submit the PDF in that homework, and I'm going to do it right now as soon as I end this Google Meet.